We just finished looking at finding the roots of a cubic. Why? Because we're going to learn and we're going to be asked to sketch cubic graphs. Now, we've sketched, as I said previously, we've sketched all the others. This is the last in the line of things that we have to basically get into sketching. For those of you doing AP, that sadly isn't the case. For those of you doing A-levels, sadly also not. But anyway, let's have a look now. Now we're going to look at sketching a cubic graph. And for those of you who love recipes, there is one, okay? Step 1, always put into standard form, which is ax cubed plus bx squared plus cx plus d. That is, and it could be f of x or y equal to that. So that's our standard form. Okay. The next step is let x equal 0 and find y, then write the coordinates, the x and the y that you found, which is going to be a 0 and a y. This is the y-intercept. Anything looking familiar at this point? It should be, because now we're going to go and continue. The step number 3 of the recipe is the following. Step 3 is let y equal 0, solve for x, in this case, possibly 3 values. Okay? In other words, we're finding the x-intercepts or the roots of the equation. Then we're going to say step 4. Okay, how do we do that? This is your calculator or synthetic or long division. Synthetic or long division, whichever suits you best. As I've said before, please check in your specific country what the educator requires with regard to the method of solution. Some people do not just want an answer written down from a calculator. Question number 4, step number 4 is the shape. And remember, we had the shape was for a quadratic, ax squared plus bx plus c. A gave us the shape. Guess what? A greater than 0, the graph looks like that. A less than 0, the graph is on the, sorry. Okay. The graph is coming down. So this one's going up and this one's going down. It's as simple as that. One goes up, upwards, and the one goes downwards. There are a couple of little bits and pieces in there that we're going to do. And step number 5, this is where it becomes different. Find f prime of x and set f prime x equal to 0. Solving for x. Whoops. I'm a bit ahead of my can you see how my brain is ahead of my hand? Solve for x. The x value at f prime of x equal to 0 is the stationary point. Because they are flat. They are a gradient, a slope, m equals 0. So it's the stationary point. So this is all we do. And we say, then once we've got those, right, we've got those x, now use these x values and find the corresponding y value. How? By substitution of the x into f of x, as you would with anything else. Remember when you found the roots of the x-intercept of a quadratic, you went and put them in to find the others, or rather the turning points of a quadratic. You went and you put it in. And then basically, number 6 is plot, and like I like to say, join the dots. Yes, there's little bits and pieces that are going to come in, but let's get this under our belts first. Here we're going to do an example. Sketch the following curve. Sketch the following curve. F of x equals x cubed minus 3x squared minus 6x plus 8. What do I do? Step 1, it says, all right, in this case, I just put step 1. This is standard form. Okay. Step 2, let x equal 0. Step 1 is that one. Step 2 is let x equal 0. X equal 0, basically, y is equal to, or f of x is equal to 8. Therefore, write it down, 0 and 8. This is my y-intercept. Okay, this is A, that's B, that's C, and that's D. Correct? Those are the constants. Then I say number 3, put y equals 0 and solve. How do we do that? We don't have a line like that. We use our synthetic division. So if I'm going to do that, I need to put my coefficients down, and my coefficients, A is 1, B is minus 3, minus 6, and plus 8. And I need to try and find which one equals 0. Okay, let me see. First of all, try f of 1. And if we do that, this equals 0. Therefore, x minus 1 is a factor, which means over here I put in the 1. Right? Because x equals 1 was a factor. Right? Yes, f of 1 was equal to 0. That is why I put the 1 there. Then I bring this down. I bring that down as a 1. Then I go red, and I say, okie dokie, red times that is 1 times 1 is 1, and I add and I get minus 2 sitting there. The next phase is going to be green, and the green one is 1 times minus 2. 1 times minus 2 is equal to minus 2. Right? Minus 2 is equal to minus 8. The blue was then 1 times that. 1 times minus 8 is minus 8, and I add and I get 0. Thus, I have now completed my, let's bring it down, I've completed my synthetic division. I'm now ready to constitute it as a quadratic. So I like to say, right, therefore I've got x minus 1 was my first one. And then my next one is going to be 1x squared minus 2x minus 8. Can you see? There they go. Down to there. I then factorize this one, and I say it's x minus 1, and this I factorize. Please remember, I might be doing this x minus 4, x minus 2. I might have to use a formula here. Some of them we do have to use the formula. It does get a little bit, you get some very odd numbers coming out very soon. Therefore, x equals 1, x equals 4, x equals, sorry, that's a plus 2. 2, x equals 2. X equals minus 2. Silly me. So it's 1 and 0, 4 and 0, and minus 2 and 0. Those are my roots. That's where I'm cutting through the x-axis, is it not? My next step is to say, okay, these are the roots, the x-intercepts. Please note, I always write an x and a y. I never just leave it, because if I'm drawing a graph, I want to go through and my eye must pick up my stuff in brackets. Those are coordinates, and I can just plot them in. My next is 4, is find the stationary points. How do I do that? Find f prime of x. Therefore, f prime of x is going to be equal to, in this case, it's going to be 3x squared minus 6x minus 6, and put f prime of x equal to 0. Straight away, divide through by x. X squared minus 2x minus 2 is equal to 0. And factorize this, because this comes out to be x1. Now you can see I was a little bit quick for myself here. This here, you use the formula and you end up with x1 equal to 2.73, x2 equal to minus 0.73. You can see the roots are no longer very pretty. So this is our stationary points, right? Now, subs these into f of x to find the y. So I go, and here I'm just going to do a substitution. Therefore, f of 2.73 is going to be 2.73 cubed minus 3 times 2.73 squared minus 6 times 2.73 plus 8. If I calculate all that, I get minus 10,39. Therefore, my points are 2.73 and minus 10,39. The next one that I'm going to do is I'm going to put in f of minus 0.73 is equal to minus 0.73 cubed minus 3 times 0.73 squared minus 6 times 0.73 plus 8. This comes out to be 10,39. Therefore, my point is minus 0.73 and 10,39. Those are my points. My next step was 5. I go and I draw a graph and I go and plot it. Okay. I'm now going to say, all right, minus 1, minus 2, minus 3, minus 4. And similarly, 1, 2, 3, 4. And let's put in a few points. Okay, first of all, let's put in the roots. The roots were minus 2, 1, and 4. Okay. Oh, we didn't do the shape. I forgot to do the shape. We'll go back to that now. Let me now plot in with blue. Let's plot in the turning point, minus 0.73 and 10.39, minus 0.73 and 10.39. The next one, minus 2.73 over there, minus 2.73 and minus 10.39. You can see those are my turning points. But now I don't know the shape, and I should have done this before. Let me do it now. Let's see the shape. A is 1, so it's greater than 0, therefore it's one that goes up. So now I can go, and with red I can say, okay, it's going to go up. hang on, there's a point plotted there that I needed to plot, which was D, which was 8. 0 and 8. And there she goes. Very, very, I'm not going to say straightforward. It's a lot of work to achieve these. All right, they are a lot of work, and at the end of the day, they're very rewarding when you get it. But you can see, I just want to put in over here with a black line. Remember, f prime of x equals 0 there, and f prime of x. You don't put this in on your graph. I'm just using it to illustrate. And there you go. Straightforward. Now, the next thing is to say, all right, we can look and say, what if we started looking at the second derivative? What is f double prime of x? Well, f prime of x was going to be x squared minus where's my f? Just let me just check. X squared minus 2x, x squared minus 2x minus 2. Please go back up and you'll find that. Therefore, f double prime is 2x minus 2. Just go back up. I'm just going to go quickly up to find f prime of x. Here we are. I'm just going to put a red asterisk there. Can you see x squared minus 2x? This is f prime of x from up there. I'm now using it and I'm doing the double derivative. I'm saying, what is f double prime x? I am differentiating that again, 2x minus 2. Now, I say to myself, if f double prime of x is greater than 0, the stationary point is we call it a local minimum. If f double prime at x is less than 0, the stationary point is a local maximum. Here's the little juxtaposition of it. If it's negative, it's a maximum. If it's positive, it's a minimum. In other words, looks like that for a negative. Okay? So a minimum comes down to the bottom. It's the minimum value that that parabola can be. We did that in ranges in earlier lectures. Maximum is the maximum point it can get to. It's the highest. It's the highest value of y. So we could check. Let's have a look and check and see what happens now. Over here, I am going to say, well, if f double prime of x is equal to 2x minus 2, now use x equals, first of all, minus 0.73. Therefore, f double prime of x is 2 times minus 0.73 minus 2 is going to be equal to negative. Therefore, it's a maximum. Now we can go and we can have a look at the next one, and we can say f double prime of x, if x is equal to 2.73, is going to be 2 times 2.73 minus 2. This is positive. Therefore, it's a minimum. Maximum and a minimum. So using the second derivative, all right, using the second derivative, we take it, and then at that x value that we've worked out, We put it in and look, if it's negative, it means it's a maximum. If it's positive, it's a minimum. They are opposites in a sense. Okay. Have a look at the second derivative. Okay. Maximum, it's a minimum. Remember, now, just a last piece on this one. Just remember also f prime of x, if f prime of x is greater than naught, it's an increasing function. If f prime of x is less than naught, it's a decreasing function. It's a decreasing function. So we could use a sine table in this. If we're going to use a sine table, I'm just going to go and redraw very quickly the graph up above. And we've got 0, 1, 2, 3. Minus 1, minus 2, minus 3. 1, 2, 3, and 4. Okay, like so. Whoops, sorry, my bad. Trying to be a little too quick perhaps. Let me just redo it, and then this is 0. Now, if you remember, we had a point over here, and that point was minus 0.73 and 10.39. Please go through this drawing with me. It's quite important. And then at 2.73, we had another one. 2.73 minus 10.39. So can you see this point's there now? What you do is you split up the graph in that. Then let's put in our roots. We had minus 2, 1, and 3. Oh, Kevin's gone too far. There we go. Kevin went to 3.73. Okay. 2.73 and minus 10.39. There we go. Now we split it up into, there's turning point 1, turning point 2. If you've got more than that, we use the sine table in advanced maths, and it's a very powerful tool to see what's happening. Now I go and I have a look at this side, that side, this side, and that side. So I say, if x is, let's say, minus 1. In other words, I look at an easy number to the left. So if x is minus 1, what is f prime of x equal to? And I say, well, f prime of x is x squared minus 2x minus 2. Therefore, I check the sign at minus 1. Minus 1 squared minus 2 times minus 1 minus 2 is 1 plus 2 minus 2, which means it's equal to plus 1. Therefore, it's increasing. It's going that way. It's positive. So in this area here, I am positive, therefore I'm increasing. This is my sign of first derivative. I'm going to put it in red instead. Positive. Then I try in the middle, and hang on, try at x equals 1. F prime of x is equal to x squared minus 2x minus 2. That's 1 squared minus 2 times 1 minus 2, which is 1 minus 2 minus 2. It's negative. So it's negative. Kevin goes and writes positive. It's negative, which means it's decreasing that way. So you can now see I'll go to 3. let's try x equals 3. I'll go to blue, shall we? Let's try x equals 3. F prime of x is equal to x squared minus 2x minus 2. That's 3 squared minus 2 times 3 minus 2. 9 minus 6 minus 2 is equal to plus 1. Therefore, it's increasing again. So this is positive here. So you're in negative territory to positive territory. That's the sign of the first derivative, guys. So what do I say? I say thus, I'm going to put it in, and I'm going to put it in blue. If I'm positive, I must be going up there. Okay, and I'm coming down over here. You can see, like so. Oh, it's 4. My bad. Doesn't affect the rest of it. I just put my green dot in the wrong place. Green dot is 4. Okay, the blue line, the blue line is actually going through over there. The gradient is positive. Slope is positive, slope is negative, slope is positive. It gives us another test on either side of the turning point. So we go to, let me just go here. We apply the first derivative test on an easy integer on either side of the stationary point. We apply it on either side of the stationary point. That's what we're going to do. So if I find a stationary point, I look at f prime of x this side, I look at f prime of x this side. If this is negative and that's positive, basically it means that I'm coming this way, my stationary point, I'm going up that way. Right? But now, what if I get this at the sign change point? Look at this. What about if I got f prime of x and it's plus? And over here, f prime of x is plus. Well, it means that it's increasing and increasing. Well, what it actually means is it does this. And this point here we call a point of inflection. You will also see it spelt with an X, I'm pretty sure. Here's another one. Okay. I get, sorry, I wasn't supposed to draw axes here. Okay. What do we got? We have, we have our point of inflection, and we had a negative and a negative. If the sign of f prime of x is less than 0, negative, and on this side, f prime of x is less than 0, negative. It means that the graph is doing this, and this is a point of inflection as well. So what we are saying is we are saying that we get points of inflection. It comes out on the graph as a stationary point. It is a stationary point. A point of inflection is a stationary point. Okay? It's a stationary point, but when we apply the first derivative test, we find that it goes up and does this. Okay? It doesn't actually turn. It's not a turning point, it is a stationary point. The last part of this, and this is not in all syllabuses, is the concavity test. All right? We say concave. cavity tests. Okay, very few do it. Basically, we're going to be looking at f double prime of x again. If f double prime of x is less than naught over a domain x1 to x2. In other words, if the second derivative is negative between there and there, it means that my graph is concave upwards. And the last part of this is they say that if f double prime of x is greater than naught over a domain x1 to x2, it means it is concave down. Very few are going to do that. And what do we do here? We say, right, it means that at this point we are looking from x1 to x2. We're looking over this domain. So we would look at various x values and look at the value of the double prime, the second derivative, using those x values. And essentially, if it's negative, it means it's concave up. If it's positive, it's concave down. Okay, and basically, we're going to look at the next one. We're going to look at using some of this information in reverse, given numbers, plotting the actual graph itself. Cheers, thanks for watching. I'll be back and we'll carry on with that. That last bit, as I say, it's in some textbooks, it's not in all. But we'll do examples when example times comes around. Cheers, bye.